You've got ChatGPT, AI boyfriends. There's sort of this whole consumer angle. And then the thing that has hit the most thus far has been coding agents.
It seems now obvious that coding was going to be the first dominant use case for AI. It's just such a perfect playground, deterministic software that it really lends itself well to being able to hedge some of the disadvantages of the non-determinism of LLMs.
We work with a 90 million token TypeScript monolith. There's nothing like that in Sweetbench.
The amount of innovation inside of AI UX is kind of embarrassing.
Yeah.
People should do a lot more, and if you're listening to this, you should do more.
Welcome to the first, the inaugural meeting of bald guys in technology working on agent frameworks or agent adjacent things. Such a pleasure to be here.
BGTN, something like this, right? That's the acronym.
I have a guy I know at one point. He said, "Oh yeah, I know Jay from the JBBL. Was it the Jeff Bezos lookalike club?" I was wearing a vest or something like that.
Nice. Well, it's a compliment. I think it means you've been hitting the gym too.
Exactly. Mm-hmm. Yeah, and I look like a billionaire.
There you go.
I think it's a great place to start. Such a pleasure to be here. Thank you for hosting me. It's a wonderful studio we've got. We've been kind of going back and forth on Twitter for about 2 years, I want to say.
Yeah.
2.5 years, sort of since the very dawn of the GPT-3 API era. So I'm super excited to get your take on a bunch of stuff that relates to agents, memory, storage, things that are sort of non-AI adjacent, but database construction. I'm also very interested to get your takes on that and see where the conversation takes us. So maybe a good place to start is AI application database. That's sort of the term that's on your website. What is different about an AI database compared to Postgres or MongoDB or anything that a developer is more sort of traditionally used to?
One way to describe kind of the modern instantiation of Chroma, obviously you're changing the messaging to reach different kind of generations of developers. Chroma is building modern search infrastructure for AI. Modern is in sharp contrast to a lot of traditional databases and systems that are really hard to scale, really expensive. You have to think about capacity planning. You have to size your nodes and do a bunch of work around backups and warm standbys and just a bunch of operational overhead. A lot of modern distributed systems now sort of abstract away all of that complexity and just give developers a much easier and more cost-effective, while still being very performant solution. So that's the modern piece. And then for AI is in some ways the more interesting piece of this conversation. We basically believe that there's three things that means. Number one, it's for AI developers in contrast to, again, traditional search infrastructure, which had to be a sort of a pointy-headed, is that a term? Search engineer to go and set up and implement and maintain. Now everybody has to solve search problems to bring the right context to agents. Number two is AI workloads. In the past, where you would only really index and make searchable certain pools of data, which were very high value, that lots of people needed to query a lot of the time. If you think about our jobs day to day, a large part of our jobs is information retrieval. I would wager that you and I are spending 15 to 20% of our day-to-day lives just doing sort of information retrieval. Imagine all the different systems you touch, all the different data you touch, right? You have a map of that. You have an index, you have routing, you're figuring out where to find stuff. And so I think the same is true as we want to move more and more labor to agents is all of that data needs to be legible to, accessible by, and searchable by agents. The third thing is AI features, which is, you can kind of break this down a bunch of different ways, but I'll give you one simple example to start, which is that in the past, your recall at 10 blue links or 10 results really mattered because that's all that a human could digest. Your recall mattered, but also your precision. Now with LLMs, precision matters much less. But recall is actually more important. An LLM can digest hundreds of results potentially very easily and cheaply, but you need to make sure that within those hundreds of results, the right answer lies. I think there's a bunch of other really interesting things that both our customers are working on, we're working on, where you can really use the LLM sort of as a query planner. It's one way to think about it. The LLM can decide and understand the intent, and they can build the query to go and get the right information out of the system. And again, these are things that are only possible now, because LLMs exist.
That's really fascinating. I've seen an application in doing sort of successive SQL queries. That's sort of this non-deterministic query planner where it'll run a query, it'll look at the schema of a SQL database, and then it will decide, based upon this, I should go query this. Mm-hmm. And it's sort of running a non-deterministic SQL query in a way where there's just determinism interleaved with non-determinism where it decides what the next thing is. Yeah. It's a very exciting idea.
Yeah. Broadly speaking, the job of most kind of AI engineers really is context engineering. And you got to figure out, how to wire up all your systems to give the agent the access to the right pools of data, teach it how to use those things. In some cases, that's going to be structured data inside of relational databases, data warehouses. In other cases, it's going to be tools and APIs that the agent, needs to know about and have access to, know how to use. In other cases, it's going to be unstructured data. You look at like the volume of unstructured data in most enterprises, it's already 100x, 1000x structured data, and that's only going to accelerate. If you think about like LLMs running all day, every day, like what are they ingesting and what are they outputting? It's more unstructured data. Obviously, we think a lot about at Chroma, the unstructured data side of things, but there's not a silver bullet here. And again, this is engineering. We have to do the hard work.
So you mentioned context engineering. To me, that's meant many different things over the course of the last, call it 3 years or so. At the very beginning, you could only fit maybe 4K tokens. I think GPT was like 4K initially, GPT-3.
It was small.
And fast forward to now, we have 1 million tokens on Claude Sonnet announced yesterday. So can you walk me through how the art of context engineering has evolved over time and how you see it sort of evolving in the future?
Yeah, in the beginning, as you said, the context windows were teeny tiny and you could do like, very small amounts of work. Now I think the largest like commercially available model is like Llama 4 Maverick. That's 10 million tokens in context window
10
length.
million.
And then, certain startups have sort of at times, made the claim that they have 100 million tokens or 1 billion tokens or infinite tokens. One thing that Chroma has done a bunch of work around also, for the people that are listening, you can go and check out our research technical report on context rot, which is the question of like, well, you say that you're giving me 1 million tokens, but how well can you actually use those 1 million tokens? This is a really important question, and a question that like the labs are not particularly incentivized to help you think of that question in the first place, nor really to answer that question. But we did the work, we did the research, we had the proof. And most developers who are practitioners that are really building stuff every day already had an intuition about this. You hear from developers all the time that like, push past 100,000 tokens with any of the Claude models, things get a little squirrely. And so like,
it's a little touch and go, isn't it?
Yeah, we just like, I don't know, if we want like reliable and performance systems, like we're not looking to add more non-determinism usually. Yeah. And so our research shows that across both the ability of the model to pay attention to large parts of the context window and the ability of the model to reason over that context, that we see like quite steep degradations as early as like 5,000 or 10,000 tokens. And so again, for your use case, it's going to change and vary like how much reasoning power you need and how much attention you need. But I think these problems are not going away. I think that it's like fundamental potentially to the transformer and just like how these models are trained. I hope that it does get better because it's kind of a pain in the butt to work around, admittedly. But like, I think, for anybody building today, you need to both skate to where the puck is going, but also understand like what the reality is. I guess just in summary, like, we're going to run the analysis on GPT-5. We're going to run the same analysis that we ran on the new like million token Claude model. We'll see what the numbers say. It's a pretty stable bet that like, at least for the next like, 3 to 5 years, that like developers really do need to like embrace and get very good at context engineering. If anything, just for speed and cost reasons, not even just accuracy reasons, but like, your classic hierarchy of make it work, make it fast, make it cheap. We're still very much at the make it work phase. And like, I think you have to engineer a context window to make it work.
For sure. Well, intuitively, so you mentioned that you don't think this problem is going away. And I remember seeing the needle in the haystack setup you had where it's like, I don't know, you put the entire Lord of the Rings series in there and then there's one line from Harry Potter. And you say, can you find me the line that's from Harry Potter? Maybe this isn't from your research specifically. That seems to me like the type of thing that you can produce infinite amounts of synthetic data around. And so if you wanted to run some type of an RL loop, you could really just grind this thing down to the absolute, bearings. If you said, find the Harry Potter line for me. So do you think that that's actually going to cap out and we're not going to be able to defend against this issue where it won't be able to like find the needle in the haystack?
A few things. First of all, that's not needle in a haystack. Needle in a haystack is actually strong lexical matches. So you brought up more of an example of a semantic match or even like a categorization matching thing where like, this sentence maybe doesn't even say Harry Potter, right? Or doesn't even say Voldemort. It's like, just I should sort of know based on my training data that like that's from Harry Potter. Like true needle in a haystack is like, one example of this is like, the question would be, what did my college professor say is the best thing to do to get good at writing? And then the needle will be, my college professor said the best thing to get good at writing is write every day.
Interesting.
And like extreme lexical matching. Like it is a zero reasoning task situation. Even if you ablate that and you just do a simple semantic hop where like you say instead, how do I get good at writing stories or something like this, you see actually, you start to see a degradation. So the like needle and a haystack strong lexical matches is solved across all token window context lengths. Again, it has zero reasoning power and also has very limited attention. You have to just pay attention to a needle. I want to just quickly add that. Going back to the question about like RL, obviously RL is incredibly hot right now. It's, it's all that anybody can seemingly talk about. I think there's two questions there. Number one, what can RL do well? And the second question is like, what can the models absorb? And like, what can they absorb without forgetting? And I don't think the jury's out on that, right? Like, we don't actually really understand, like, from an interpretability perspective, like the limits of these things. If you probably can make a model that is extremely good at like, categorizing Lord of the Rings content versus Harry Potter content, will you lose everything else in the process?
Right.
Maybe not everything else, but most of it.
So if we look at the general distribution of like any possible book and there's like a one line from Harry Potter thrown in there, maybe, it's unclear how good we're going to get. I think when you typically look at long context loads that we're seeing in production today, it's usually like very long agentic rollouts.
Correct.
And I'm curious, do you have any thoughts on like in that specific sub-distribution of data, which is just agentic long-term rollouts, is it better? Or is there any evidence to demonstrate that like we're better at remembering stuff then?
I'm very bullish that like more, on a percentage basis, like the percentage of like fine-tuned models, RL or otherwise, the percentage of workloads served by those models will only go up year over year, probably infinitely. Probably the next 40 years. And today it's quite small, right? Most people are just using like base models. Well, maybe not base models, but they're using like the RLHF, like chat models primarily. I don't know the percentage of models that are, kind of like fine-tuned on a specific task, but like, I think it's probably single-digit percentage points, if not lower, maybe like sub 1%. But like I think that will go up year over year. And so I'm like actually long, like, purpose-built models. I think that like that's the best way to get to the level of like reliability that we want. The part that I'm like skeptical about more so is that that's like a panacea. I'll give you one example is like we were doing some experiments. We actually are continuing to do more experiments with SweetBench, and we looked at long context in the context of SweetBench, right? Sort of agentic rollouts, lots of iterative, kind of tasks. If we gave the agent access to prior success cases and or prior failures, does it improve agent performance? Intuitively makes sense, right? As a human, have the cheat sheet. If you can figure out, I hit this problem before, this is how I'm going to fix it. That seems like it's going to, be good. Or, few shot prompting, right? Like, I've seen X, 10 situations like this before. This is what I did. This is what worked. Now I can just copy that. And so we found, again, this was like a limited test. And so there's a bunch of disclaimers put on it. But what we found is that like when you gave this agent access to prior failures, it boosted model performance. Something like, what are the percentage points? It was significant. It was like, something like 25% to like 33% or something like this. When you gave the agent access to only prior successes though, agent performance went down.
Really? That's super unintuitive.
I think it's not unintuitive once you unpack it. We'll see if it's intuitive or not, I guess, once we unpack it. So I think the intuition is that like models are lazy. The most insidious, distracting information is the information which seems highly relevant, but is not, for a subtle reason. And the models are not always capable of appreciating the subtlety. You can imagine you as a human, right? You take a human who's not an expert at doing something and you ask them to do a task, and then you give them access to a corpus of, previous examples, like they are also just going to sort of fall into that local minima and sort of resort to copy and pasting. Hey, you already did the work for me. Thank you very much. I don't have to think right now. I'm just going to copy and paste. And so, yeah, that's what we found.
And just to clarify, when you say a library of prior successes, it was successes on related tasks, but not the exact same task. Because you could have a copy-paste machine that would just take the diff from the success case and apply it.
That would be not an interesting test in some ways. That would just be true cheating. Yeah.
Okay.
No,
That's why
it was similar, but not the same.
Got it. Okay. That is a very interesting result. And I wonder if that carries over to training as well. I've seen a couple of results that have demonstrated that there's like a continuous, there's a continuum between packing context with in-context examples or few-shot learning all the way to actually doing fine-tuning? And are the negative samples actually more valuable in a SweetBench context than the positive ones?
1,000,000%. I mean, this is actually, in a weird way, like where Chroma started. We were really interested in active learning, which is fundamentally the process of like, the fundamental question of active learning is like, what should I train on next? And what you want to identify are examples that are difficult, out of distribution from what you know already, but learnable. So difficult, but learnable. There's many tools obviously to like kind of gather that signal. But actually Google just like last week released like a new paper like on active learning.
I saw that. Classification of examples, which ones are going to be helpful.
Right. And they actually I think they use embedding spaces to like kind of derive these sorts of things. And we are starting to see like a few of our customers use Chroma like in like training as well, which is pretty cool. So I think it's still super early, but yeah.
Is there a way in which you can actually embed something like that into the vector database itself? So you have these embeddings, then you can somehow have like a inference layer baked into the DB, like at the C++ level that allows you to do a projection onto a single scalar value that, tells you like this is valuable or it's not. Maybe not just for active learning purposes, but for other classification purposes.
The term vector database I've always hated and I will continue to hate. So I'll just add that really quickly. I think it's it's sort of a brain rot term. It doesn't describe actually what the job is here. But besides that, I think LLMs running inside of databases are really interesting. I think the process that most retrieval systems, you can kind of reason about how they work, is that you first want to gather all possible relevant information. But then again, as we've already discussed, you can't give all of that information to the context window. It can't handle it. And so you have to glean it down. You have to focus it somehow. Re-rankers are a common historical tool for doing that. These are sort of dedicated cross-encoder, bi-encoder models, specialized on ranking specifically. We're seeing more and more people use LLMs directly as re-rankers, or it could be, binary classifiers. Here is the prompt, here is a chunk, is this relevant, yes or no? The output tokens are basically 0. You can just use the logis directly. But if you extend that, you can go further.
Yeah, one more.
And you can do stuff like, oh, maybe it's not just binary classification. Why can't you do dynamic chunk rewriting? Here's the context, here's the chunk. Focus this chunk down to only what is relevant for this query. Or why can't you do semantic analysis? It starts to actually look more like a unstructured query engine where you can almost ask any query of a pool of data and then have massively parallel LLMs helping you process and understand that data. That to me is a really exciting future, and I think will come to pass. Obviously, I think today people are still having their minds that inference is expensive, which obviously it is if you're using the latest and greatest models. Though the cost of tokens may not go to 0, truly, people running Quen 2.5 themselves on pre-committed GPUs, et cetera, they're getting the costs down really low. I think it's a penny per million input tokens or something like that. And so it starts to almost feel like a free resource. It's almost like using electricity in your house. You don't think about it. You just throw compute at the problem.
Yeah, and in that conversation of running LLMs is expensive, I think one thing that people don't really mention is that you're already spending a lot of money on running your database. And if you can actually take the LLM across that blood-brain barrier and bake it into the foundations of the DB, you're actually probably going to end up reducing the total number of queries you do because you'll get the answer in fewer number of total queries. I'm very bullish on this idea that you would have a smarter query planner that's actually in some ways non-deterministic, running on a GPU that's just bolted onto the database, as opposed to expecting external agents to be an expert in how Chroma works.
I think we've always believed that data has gravity and that eventually compute workloads come home because they come to their data. And that can obviously be just sort of network egress, transfer cost reasons. As you said, in the future, maybe build a sort of page directly the data we want for context or retrieval, directly onto GPUs. And so all that living on one chipset would make a lot of sense.
For sure. And it stands to reason you could do hardware level optimizations on these things. So they're, better specifically at using your data storage format in order to do retrieval, better for your tools. You can train a very lightweight one, et cetera. Can you actually take us through some of the nuts and bolts of how you guys are thinking about that and any implementation efforts you've had to date? Do you have fine-tuned LLMs that interact with the Chroma DB, whether they're outside the DB or inside of it? How do you think about basically making customized LLM tooling to interact with Chroma?
We've done a bunch of experiments, and many of them are very promising. I think to date, just as far as small companies go, we've been really focused on doing one or only a few things very well. So we've been very focused on making the database very fast, very cost effective, very performant, very reliable. This is what our customers want us to do. Now we're starting to see more ways we can help our customers with things like data ingestion, potentially embedding model inference. And so we're making some sort of baby steps in that direction, I would say. But there's a lot that we have planned and want to get to, but it's a question of focus and time.
Totally. Yeah. And you would be probably saving cost and time, but we're still at the make it work era for many of these applications. And so maybe it doesn't make sense to bring it, the LLM across that blood-brain barrier, as it were. Let's talk about code search. I think this is one of the most fascinating areas right now. Obviously, in terms of just the revenue that's been generated from AI applications, you've got ChatGPT, AI boyfriends. There's sort of this whole consumer angle. And then the thing that has hit the most thus far has been coding agents, truly, right? We're seeing 600 million revenue from Cursor. Claude Code is not far behind. There's a lot of challenges in coding. One of them is finding the right stuff. You mentioned Sweetbench a second ago. These are fairly large code bases, but ideally we could get these things to work on significantly larger code bases. So, we work with a 90 million token TypeScript monolith. There's nothing like that in Sweetbench. What are the challenges to making this work? What is Chroma doing in order to help? And how do you see code retrieval evolving in the future?
I think in retrospect, it seems now obvious that coding was going to be like the first dominant use case for AI. It's just such a perfect playground of deterministic software that like it really, I think, lends itself well to being able to hedge for some of the disadvantages of the non-determinism of LLMs themselves. I always go back to sort of like the Andre Karpathy, like software 1.0, software 2.0 type idea. Like, what did we do when the internet came about? We put phone books on the internet. Now that we have like AI, like sort of software 2.0, 3.0, depending on how you count, like what are we doing? We're primarily using it to write software 1.0. It's like the case today that will change. And it's obviously a ubiquitous case. Companies, there's been so much, dare I say, like propaganda about like how to do or how not to do code retrieval.
It's called back propaganda, actually.
Back propaganda. I like that. You heard it here first, folks. People should spend less time on Twitter. People should spend more time with their benchmarks and their own evals and like figuring out what works. There was certainly this era where people were saying that like vector search is all you need. I never said that. Chroma never said that. But like that was the thing that like many vendors were pushing. Obviously, we don't know what the future holds. Maybe eventually, sort of these dense representations can, be way more powerful than, sparse representations. But like today, it's not obvious that is a panacea for any application, no less code search. Famously, some companies, whether it's marketing or not, have sort of like made it a key point of their differentiation that like, no, we just grep. And of course, grep is just regex, right? You're doing like regex search on top of a set of files, which works well which can work well, especially when you have textual data. I think like it's actually useful to unpack this a little bit and to help people understand like when semantic search versus lexical search like makes sense. Also separate out indexing, right? Which is actually like building an index on top of either semantic search or on top of lexical search. You can just brute force semantic search. You can brute force lexical search at a certain data scale. It makes sense to index it because you bend the curve as you scale. One simple analogy I use, which is not directly a coding analogy, though I'll bring back to code in a second, is like, in my Google Drive, if I want to search for the spreadsheet that has a list of all my investors, I know what that's called. Like I made it. It's called cap table. And so I just want to type in cap table. There it is. There's a search result. I click it. Great. That makes sense because I'm a subject matter expert in my own data. I know the grammar. I know the language. I know what to search for. If I'm not a subject matter expert in my own data, then, okay, well, I'm going to search for like the spreadsheet that has the list of all my investors. That semantically is going to match very high to cap table, naturally. And then, I'll click on it and go forth. So I think you can think about this like for any given use case or user or both, a mixture. There's a certain blend of like how educated is the agent or the human in the grammar and the dictionary of the content that you want to search. There's sort of a blend of, I think, some applications it's in terms of utility, it's 80-20. Other applications it's flipped, it's 20-80, depending on which of these techniques are going to be very useful. People have found that like LLMs are really good at code. They've been trained on a lot of code, and so they're actually like pretty good at the grammar, and they're pretty good at like guessing like which terms to search for. And they get those terms exactly right or very close, and so regex is a very powerful tool as a result. I think it's again the way to kind of unpack and like think about this. I think it's like kind of code retrieval broadly. I think the jury is out on like whether regex is all you need. The jury is out certainly on whether dense embeddings, vector search is all you need. I think that like in likelihood, the reality is that it's going to be a mix. And obviously like when and how to use what is like the interesting part of context engineering. But again, this is like, I think really what does differentiate like the tools people love versus the tools that people do not love is like how good is the system at pulling relevant context. People I think are tempted to like lean on the crutch of like, oh, you can just have the agent agentically search, agentic rag. I never want to say that again. Just like keep going back to the well until you get something that like seems like it works. But I think you have lots of problems there too. Like how does it know when to stop? What if it stops too early? Like in some ways you're just adding like more non-determinism to the system, not less. And so while that's useful, don't get me wrong, we already talked about like LLMs being great, they can be like great query planners. The agent querying 80 times until it finds the thing that you want is like not likely to be the dominant feature of the application that users love a year from now.
So then do you have a perspective on if we were to make custom tooling for an LLM, let's say it's like a language server on crack, something like that has the structure of the domain baked into it. So it's not just doing lexical search, but allows you to like jump to reference for a given symbol or something along those lines.
Yeah.
Do you think that would actually solve some of the issues you described?
Yeah, 100%. I mean, this is what a lot of the top companies are already doing. So they're using RegX, they're using simple search as like two very like key techniques. They're also using semantic search in some, specific cases. Some of them are going even further and pushing, more advanced stuff. Again, going back to like the gather and glean analogy, first you want to like get all the possible relevant tokens or information, and then you want to glean, kind of focus it down to like just what you need. If you think about like, what do even more and more sophisticated approaches to like searching, if you will, what do they buy you? They might buy you a faster and cheaper gathering process. But like that might be on the margin, not that important. It's possible that like brute forcing it at the glean stage, if you will, is kind of where most of the value lies. And again, you can always make it 10, 15% better, cheaper and faster, which like users may or may not notice or care about, depending on the user and the situation. But I think, again, you have to tie it back to the actual difference in the user experience and the difference in also the ability of the agents to. I don't know that like that will in the long term make a huge difference in the ability of the agent to perform, I guess is what I'm trying to say. Mm-hmm. I think if you do a good job gleaning, you'll still come back to all the relevant tokens. I think what it will mainly do is make the agent loop, again, on the margin, faster and cheaper. And then whether that matters to your user is a separate question.
For sure. Yeah, in a way, the file system is a database that exposes various search techniques over it, including ripgrep or whatever that may be. And it seems like a huge reason for why that has won thus far. So Claude Code will just use ripgrep. It doesn't use any fancy language servers or anything like that. And that is, as far as I can tell, state of the art. It's just super easy to set up. You don't have to know anything about a specific database or query methods. It's just good to go as soon as you have a Linux VM. I have a hard time believing, though, that's going to be the case in the future.
Yeah.
Like, it feels like there's so many things that are inherent to the structure of code that you would want to leverage for a hyper-intelligent LLM to be effective. Language server is a good example of that.
Yeah.
You might not know what to call the authentication module, but instead of running like 6 ripgrep queries, maybe you want to actually do a semantic search in order to retrieve it. There's obvious complexities associated with creating the actual vector database, but that seems like the type of thing that will end up being resolved in the near future. So, and not to mention, searching the entire web's worth of code is not something you can do on a single file system.
Exactly. Yeah. I think I'll also make the point that like, if you're just searching text, then maybe RegX can get you most of the way there. Again, if it only gets you 80% of the way there, if adding semantic search, embedding-based search gets you another incremental 8%, that might mean the difference between a user selecting your product versus a competitor's product, right? And so like, It's not necessarily all about like, you have to think about these things. Text search, by definition, is only good at searching text, which in the case of code is usually only text, but not all the time, right? Like a lot of multimedia ends up finding its way into the public folder, if you will, of your code base. And so like, how do you search images? How do you search video? That's also, I think, an important consideration if you want agents to truly go that like last mile of like utility and reliability. Another thing that I'll mention is like today, I don't know of any agent that does this. I'm not like, totally up to date on everybody's latest and greatest features, but like today it seems like most people only search like the current active commit, the current dirty state of like whatever, active commit is on your local machine. They're not referencing other branches, not historical or other open branches. Which seems like it would be very useful, actually, especially if like 2 agents working on similar features and separate branches. Maybe they should like coordinate to some degree and not create some like ridiculous merge conflict down the road for the human. That requires you, by the way, to be able to query them, sort of in real time simultaneously. Those are separate search indexes, and you have to think about how to do that. We've built some features. One feature is called forking, where for a given collection, you can create a copy of that collection in under 100 milliseconds, which enables you to skip like the cost and time of reindexing, and then you just land the diff of either the dirty state or whatever commit you want to search like down into that index. You also save a lot in storage as well, because you're not paying for you're only paying for the incremental storage. And so we see like a lot of AI coding companies using Chroma, like specifically kind of in that way, where they're doing like tons of forking. They're creating tons of forks of collections to search. The other thing that I'll mention is not just searching like your code that you're working on, but searching the open source dependencies on which your code relies, right? We've all seen like the famous, is it XACD comic, right?
With like the
tower of dependencies, right? Today, and maybe in the future it'll be by LSP or otherwise, right? But like, it seems like today most AI coding agents like don't like click into references and go look at the actual API reference. And so like, if you're using that version of Fast API or that version of React, like it increases the chance of like hallucinations, because like, I don't think that like models, maybe with huge libraries like, Fast API and React, like the model, if you ask it like at this specific version, what is the API? I think it might be able to get it. I've not tried. But like, I think the long tail is really hard. And so like increasing like agent reliability on coding, let it look at the references, let it look at the open source dependencies. Mm-hmm. But you don't always want to like git clone and do npm install and wait 5 minutes for your agent, right? And so then like those things I think also need to be pre-indexed so that you can quickly kind of get in there and start writing code.
Yeah, and sometimes they're already minified, so you don't get good documentation if you do npm install. Yeah,
exactly.
So is this an active effort that Chroma is undertaking? Yeah.
When is this going to be published?
This will probably be like a week or 2 weeks from now.
Yeah, we actually then just released we
can wait until you publish this. Maybe that would be
we call it code collections, and we've indexed like all major open source dependencies across npm, PyPI, crate, and for Rust and Go. Cargo and Go. You can search them across various release tags.
That's amazing. So I can pin a version and say, tell me what the API supported was in this version of this obscure package.
Yeah. I mean, basically, you're just giving more tools to the agent. So you say, okay, I want to search like this exact package at this release tag. And you can do a RegX search. You can do a semantic search. You can do both. You can do file-based search, metadata. It's all in there.
That's super cool. I want to revisit this idea of a forkable collection. I think this is actually a pattern. I've spoken to a lot of folks, in the space of agents and coding and whatnot. This is an idea that keeps coming up is because an agent is something that it seems like they're going to be RL'd in the future with just an agent tool where it can fork itself. Any type of an artifact it's working on, if that artifact is also forkable, so maybe it's a VM, maybe it's a Git state, you have obviously like stacking PRs and whatnot, or a collection, seems to make a lot of sense.
Yep.
And so what you're describing here is you have, a situation where you want to be able to index a code base, and then on different Git branches, you would have different collections that you can search that are in some way copy on write. So it's very easy to spin up a new copy. Is there a future in which you would actually bring that into Git itself and have some type of a Git extension where it's like a searchable index that has a diff stored for each commit?
I'm not sure that I want to cross Linus ever. So I think the integration at that level.
What's the order of magnitude we're talking about here in terms of the size of the index? Is it vastly larger than the actual code itself?
There's so many variables, right? It's like how you chunk it, how large of an embedding model you use, if you quantize it. That's the main difference or challenge. It's configurable, I guess, depending on like how large or small you want it to be.
That's super cool.
Yeah. I mean, as we know, Git is not exactly good at like large file management, right? Anybody who's used Git LFS will never use it again, usually. Moving around, while portability makes a lot of sense, like you do want to like ship like the index with the code. You also don't want to be moving large files over the network at kind of agent runtime either, because it's like just going to be slow and expensive. You want to search remotely and like just get the data you need, not move the whole index over. So I suspect that will not become a dominant pattern.
The other thing you mentioned that I thought was pretty thought-provoking is this idea of searching across different commits. So you're absolutely right. If you told me to go implement a feature, Jay, as a developer, I'm not going to go look at other people's stuff. I'm just going to start, looking at the code that's on my machine today. That does seem like the type of query, though, where you would want to dispatch somebody to do sort of background research for you, right? So maybe there's a specialist agent that just will look at prior instances in a code base. It'll do Git archaeology, look through all previous branches and find for you.
Yeah.
Oh, we did actually do this in the past, but that doesn't actually block the main thread of the agent going forward. And this seems like the type of thing you could actually bake into the database itself. And so I would say, hey, find me all instances of X, has a fast response to me. So it says, hey, in the code base today, on this commit, this is what we're looking at. But also just sort of an async query in the background. So I'm curious, do you think about applications like this where there's like a multi-tiered?
It's a good question. I think one way to think about this is like budget. So for some queries, you want to spend very little money or very little time or both, and you want to answer very fast and very cheaply. For other queries, you're willing to spend a lot of time or a lot of money conceptually to like go and get the right answer. That is, I think, falls more in the purview of these sort of like background search agents. I think the term that people use is deep research. Like, this is kind of like a deep researchy type thing. I don't like that term, but that is what people call it.
Why not? What's the issue with deep research?
I don't know. It's just another dumb term that doesn't mean anything.
I think it's the first company to get it across the finish line gets to coin the term. And unfortunately, deep research was...
Has anybody got it across the finish line? Like, you've used deep research presumably, right?
Oh, yeah.
Like it kind of sucks. Like if you run it on something that you know about, you're like, this result is incredibly mid and like wrong in like subtle ways, but meaningful ways in like 10 or 15 different places. And like that should make you very skeptical to use it for any other task that you care anything about. Because if it's not good at something you know something about, like why should you trust it to be good at something you don't know about?
I don't know if my experience has been the same. I mean, I guess I'm not asking it questions where I'm expecting PhD level research. I'm rather looking for something where it's like a quick book report where it's retrieved the relevant links from CNN or PyPI packages or whatever, and it's verifiable when you look at the output. Like you can actually see that it got the right answer. But I have no trouble believing that if I was to ask it a difficult problem, that it would not be able to get it.
Yeah.
I think that'll be solved soon.
Yeah,
I do think it was one of the first products that launched in a full-on consumer manner that actually tried to do like an agentic task that took about half an hour. Like prior to that, really, you only had ChatGPT, which would run for 5 minutes or something along those lines. And so for that reason, I want to give it to ChatGPT or Google or whoever launched it first and say, deep research, great. You guys get to pick the name and I'll call that sequencing. Yeah. But I guess there's deep research, but there's also multi-tiered research. So like you should be able to specify, okay, I want the ability for this thing to come back and interrupt me with like updated information on the question I've asked.
Right. I mean, not just like give you sort of status updates and reports on like how it's going and what it's thinking about. It's kind of streaming those tokens back, but also potentially asking you for clarifications if it needs additional help. I mean, it's something that even like deep research tasks today like don't do. My understanding of like how deep research in ChatGPT works, for example, is that it's actually like obvious if you use it, but it is like hardwired to ask you a question. Like it will always ask you first a question. You notice it never asks you another question, even though it presumably could or should. And that will change. We'll do whatever our customers want us to do is the long and short of it. I think like today, that paradigm we've not yet found to be common or popular enough where people want us to do it. And I think that's probably mostly about the maturity of these things where they're not stable yet. And there's
I agree.
Like the change is so high that like people rightfully so want to keep it like in their purview directly, like very directly. And then once it becomes like standardized and well understood, then there be gains, speed, cost, reliability, operational complexity to like sort of like farming it out. So that's my guess. But
yeah, I would probably add on that to say one of the reasons you don't see this in production today is because the high watermark or like the maximum length you can get an agent to run and actually do something valuable is between an hour and 2 hours. And if a full half of that is just doing research and spawning a sub agent that goes off and look for stuff, you should just have the main agent thread end up doing that. But maybe as we anticipate these agents are running for 10 hours or 24 hours or something like that, it actually does make sense to spawn off little mini deep research agents that come back with verifiable information for you.
Yeah, I like that.
I think, as you see the length of the main thread gets longer, then the size of the agency it can support will almost certainly go up, right? Because there's just more things to be done that you can actually, make use of.
Yep. There's some like direct analogy to companies, it feels like, where like maybe this has a breaking point clearly, but it's like, what you find is the correlation, at least, that like the larger the company, the farther into the future, supposedly, they at least have the ability to look. Not that all large companies do look far into the future, but like in theory, the larger the company, the farther in the future they have the ability to look.
For sure.
Yeah.
So we've talked a lot about retrieval of code or like artifacts that are maybe like information in Slack or something along those lines, which is obviously going to, it's the wave is still yet to crash, I think, and there's going to be huge productivity gains that comes from this. One of the most frequently cited interesting use cases for retrieval is memory. So it's not just the actual read portion, but also the write portion of what do I decide to remember in the first place. I know y'all have spent a lot of time thinking about this, so I'd love to get your thoughts. Maybe as a motivating question is, what do you think are the actual good applications of memory that exist today? Like where has it been successful? And what do you think those applications will be in the future? And then how do we pull that off?
I think broadly you can split. I mean, first of all, memory is it's not a technology. Memory is a benefit of a technology that is legible to the average person. Your mom and my mom sort of can understand what memory is and means and kind of why intuitively it would be beneficial. That may also be true for like the C-suite, right? Oh, memory, I get what that would be. I want my agents to have memory. Like that kind of makes sense. I think in practice, for the practitioners who are actually implementing this stuff, the read path is just another context engineering path, going and gathering relevant historical information and deciding what's important or not, and then putting that in the context window and then using it. The write path is interesting. So like, what should the system remember? Broadly, the system should remember anything that allows it to get better at the task at hand. I think that's one way to think about it. So like kind of agent continual online learning, something like this is like the goal of memory in my mind. I think you can break that down. You start to break things down, you create like kind of potentially false hierarchies and dichotomies that like can create more brain rot. But I do think that like there's some useful distinction between agent task learning. So like how can this agent get better at the specific task? And then user personalization. How can the agent get better at serving this user? Now, of course, serving a user is also just a task at the end of the day. It is intuitive to sort of break it into those two big buckets. Agent task learning, we've already talked a little bit about when we were talking about Sweetbench. It actually like was that experiment to see like past successes, past failures, can the agent reference those and get better? And it was obvious that this is not it's not just trivial, right? Like you don't just give it access and call it a day and right off into the sunset, go sit Mai Tais on the beach. No, it's actually way harder than that, at least today. I think it will continue to be very difficult. User personalization in a way feels more tractable and more accessible. And so, remember that I want my TypeScript formatted like this, and that's kind of the coding example, right? Or, always remember to write a test anytime you write a new function, these sorts of things. User personalization, also kind of just like user instructions, like my preferences. I'm not, but like, in theory, I'm lactose intolerant. And so if you're planning a trip to London, don't suggest me going to get ice cream, right? Like, these sorts of like kind of user consumer stories, I think also have real utility. The memory feature inside ChatGPT is contentious on some level. Some people, it seems to drive them into a deep state of psychosis and, they literally go mad. Other people, I guess, including myself, like just turn it off. Because I just want to manage it and I don't want the leakage. It's not a contentious or sort of contrarian opinion to claim that's not been done well yet.
Nothing makes me madder than when my AI waifu forgets what I said to her yesterday. So I empathize with them.
I'll avoid making jokes with that. It's funny. Yeah, exactly. Yeah, I think that like, choosing what to remember is pretty interesting. So in some level, you may not have to choose. You can just remember everything in your like gathering, glean, information retrieval pipeline broadly later. You can then decide from everything that I know about, like what should I kind of pull into context here. That may work well for like factual information, especially when the user says explicit things like, please remember X or please remember Y. I think this is how like the windsurfs and cursors currently do it. Like they kind of have these like magic words where like if you say something, then it will remember it. I actually think that like that's fine, right? Like teaching users a minimal amount of user education about like the UX of the product of like how to remember stuff, like even clicking a button, why not? Like getting that level of structured data from an end user like solves so many problems for you. We're doing it in a totally background implicit way, like is just way harder and maybe not that much more valuable relative to the users being very explicit about their preferences. That works well for like point facts and like, point information. We do see that like, if you just use a text file to sort of put all of these like preference data into like just a text file, and then you're just like throwing that thing into context every prompt, like that's dumb. Not just dumb, but like it doesn't work well. That's what I mean. And so like you shouldn't do that. You should still be discerning about what you put in the context.
It ends up giving it a bunch of deluge that's irrelevant, or?
Yeah, and the example that I use, maybe I'll find a better example eventually, is like if I'm planning a trip to Paris and last month I went to Prague, and like, in Prague I went to a pinball museum. Maybe I love pinball. And like, so I'm going to Paris now, like it should probably recommend, if there's a pinball museum in Paris, it should tell me about it. Obviously, that's a really important thing. But like, if I grew up going to my grandmother's lake in Wisconsin, and like now I'm going to Paris, it shouldn't say like, oh, you should go check out this lake because you went to a lake as a child. Like, no, like that's not important. But I think it's like hard for agents to discern like what is important and what is not important.
Yes. Gentle pushback on that isn't that sort of post retrieval? We've already gotten all these memories. The agent should be able to discern and say like, okay, this is a lake house, but he was 5. Now he's a grown ass man and he's going to.
Again, one would hope, but it just seems that like that's not a stable assumption today.
Empirically, that doesn't end up actually panning out.
Yeah.
Interesting.
The nuance I was going to add is I think that like, sort of point factual information is likely well served by some of the techniques we have today, but like long-term analysis of like not OLTP, but OLAP, right? Not point queries, but aggregations. Mrs. Agent, has now done the same similar task 45 times. Like the 46th time, like how do I get better at this? Like how should I adjust my system instructions? How should I adjust my system instructions? How should I adjust the information that I have access to or how I access it? Potentially even how should I modify my own weights such that like I can do better at this thing next time? I think that problem is like very much like underexplored and not solved.
So I was just going to ask, so, all of the implementations I'm aware of memory today that are in production, something along the lines of writing it to a to-do list or storing it in a database somewhere and retrieving it later. Do you think there's a good fundamental reason why this isn't baked into the models themselves?
What would that look like?
One example I can imagine is that, you want auditability. And so anytime it remembers something, you should be able to view it in a Notion document, or you should be able to view it in, a Postgres UI that says, okay, I can go through and I can cross out things that are irrelevant. And so if it's, actually baked into the weights of the model, it's not a good idea.
Yep.
However, we're talking about this sort of like vibes-based understanding of how to do a task. And that seems like the type of thing that there's sort of, you're adding a bunch of extra steps if you have to store it in an external database. And if we think about what does the fully generalized version of this look like that's going to be successful, it probably is doing this like lifelong learning thing that we've described, where every time it does a task, you give it some type of a error signal and it's able to just update itself in a way that's not just behavioral, it's actually memory oriented.
I mean, that would be great. The auditability questions are quite important. There is a dearth of research in applied AI broadly. The labs are very focused on the next big model that hill climbs and maximizes all the legible benchmarks, because like that's just how they accrue eyeballs and dollars and talent, and whether or not those benchmarks really mean anything now and whether they're actually helpful and whether we should care is a important question to ask that nobody seems to ask. You have a bunch of people at like the sort of SaaS layer, like building useful stuff with AI, but like don't have like the time or the org chart or the skills to like do great applied research. And so I think there is like a gap here. That's the first thing that I wanted to say. I do think that like fine tuning is very promising, especially where that fine tuning is easily like roll backable, more like LoRa shaped things. I think like are very promising. You almost want, again, like a tree of state that like you can roll back very easily, and also like hot swap very easily, like in production.
It goes back to our discussion of forking an agent.
Exactly.
You can have one agent build up some memories, but then you can go back. I think that is pretty key, that there should be an external data structure that's not actually the parameters of the model. So it's very easy for you to swap in and out, like LoRa, as you mentioned. What about applications of memory? So I think this is one noticeable thing that I've noticed as an avid agent user. I think ChatGPT and Claude launched it today, I want to say, where we'll be able to respond to your previous things, and it will say, oh, I see you're a software engineer, and therefore, and it will give me an answer. It's probably doing some form of, retrieving a bunch of documents from previous chats. Maybe they're distilled and shows it to it.
Yep.
The only other applications I've seen of actual memory in agents today are in a couple coding agents. So Cursor just rolled out a thing where it will, like you mentioned a second ago, it has maybe a secondary model that looks at your chat and says, is this memorable or not? And it will propose a memory. It's pretty bad. I'm not going to lie. Like I've been using it for a little bit, and the memories it's proposing are like, oh, you always like using this emoji in logging. And I'm like, well, I did in this specific instance, but, and I'm not claiming that's not resolvable. It's like definitely giving me the type of thing that with proper context management and engineering, you'll get something good, especially if people are clicking the button and you get this concrete feedback. Do you have any examples though, where memory actually does move the needle in terms of the experience of a user interacting with an agent?
I think intuitively, we want agents to perform at human level or beyond. And if you just consider how you teach a human to do something, it's not really possible to like write the whole user manual and write the whole textbook and have the human read it and hope that they just do it. Like in practice, any job is an apprenticeship model. And there's a lot of like tacit knowledge, which is required, like on the job training, they call it, right? Where like you are giving feedback to your employees or to people that you work with about like, do more of this, do less of this way, do this that way. I think if we want agents to be as reliable as humans, then like that has to also exist in agent land. It could be agents themselves giving themselves their own self-critical, self-critique feedback, or, I think even more likely for the time being, it's going to be humans giving agents sort of this like iterative feedback. Here's what to do next time. That seems like a very big and important problem to solve. But if you can solve that problem, I think that like the reliability of AI agents will go up massively.
To what extent is that a consumer behavior that needs to develop? And I guess as a precursor to this question, I started working on coding agents 2 years ago. People just had no idea how to use them effectively. They would give them tasks that were like, oh, fix my code base. And it's not exactly clear what's wrong with your code base. And so it would go nowhere. And we've seen in the interim between the launch of GPT-3 and now, there really is this sort of ingrained customer behavior, user behavior of this is the type of problem I can factorize out and have an agent go and do. And it seems to me like we do not yet have this muscle in users themselves to say, this is something that's worth remembering, and building this muscle of sort of active knowledge curation. So to what extent do you think that's actually the bottleneck to successful deployment of memory?
I don't know.
Wait and see.
Yeah, I think it certainly can get better, whether it's going to be like good enough to get across the line where it like reaches some sort of, activation point for a lot of use cases, TBD.
I would imagine that it's the case that if ChatGPT had a thing in it where it would say remember or don't remember, and there was just this sort of universally accepted UX mechanism, then we would end up seeing memory much more widely deployed. And you could expect if you're launching a new product, you could have a memory feature baked in. And in fact, people would expect that.
I think that's right. I mean, OpenAI has this ethos of like the most minimal brain and kind of DX or UX possible, which I think probably is the right call for a mass consumer play, like clearly what they're going after now. Problem is that they're also like they're considered to be kind of the forethinkers and like what AI UX should be like. And as a result, everybody just sort of cargo cult copy and pastes exactly what they're doing onto their thing. And the amount of innovation inside of AI UX is like kind of embarrassing.
Yeah.
I think that people should do a lot more. And if you're listening to this, you should do more.
It's interesting. There was a period where people were saying chat is not the final paradigm for human agent interaction or human LLM interaction. Like we need to do something better. And we sort of rode that wave up. And now we're coming down. People are like, actually, chat is pretty good. Like we've tried a bunch of other stuff over the last couple of years. Nothing has truly landed in the same way. And I'm curious why. Do you have any thoughts on why that might be the case?
I think chat is good UX because humans understand it, because we chat all the time. And so like it is extremely intuitive for that reason. But not all power tools are intuitive. By definition, power tools are usually not intuitive. They require you to learn them to unlock their powers, if you will. And with something like coding, that is a good candidate for a power tool. And that's a good candidate where like, just basic chat, like, may not be enough. And I think you already see this to some degree, right? You can like tag files and stuff. You can kind of give it additional context. I don't know, you can author tools or kind of give it access to tools and just things you can do. The first thing people usually jump to when they say that chat is not enough is they say, I want branching chat. And now all of a sudden you're making some sort of like, reactive node diagram thing in React.
Never works.
It just never works.
Has never worked in history.
It just never works. Maybe in 2025. Wait, no, 2035. It will work, but it just never works. I think one way to think about this is like, how can you give an expert human better information about what the agent is doing at any given point in time and intuition about as well? And then how do you give the human the ability to course correct, refine that agent's actions in real time? It's sort of anybody's guess on what that should look like. So,
for sure.
Yeah.
Yeah, it's interesting on the branching agents. I think it's important to clarify that branching agents is definitely going to be a thing. In fact, it already is. Claude Code is a great example of that. But even with that, people have still rendered it into a linear chat history because that's just easier for humans to wrap their heads around.
Exactly.
And so the actual visualization is not one of these fancy D3 charts where you can drag around and react and whatnot.
Exactly.
There probably is a visualization like that would be helpful to people, but it just hasn't caught on. So, well, I think that's a pretty good note to end this on. So thank you so much for taking the time. It's super interesting to hear about everything you guys are doing at Chroma, and appreciate you having me.
This has been awesome. Thanks.
Awesome.